Hello students, welcome to the physics session. We will be having a brief session on relative velocity, especially based on riverboat problems and rain umbrella problems. So all are there, right? CC2 up. Guys, are you getting my voice clearly? Online students, if you are not getting the voice, you can drop a message here in the drop box or chat box. Are you getting the voice clearly? Respond someone. Okay? Right, okay then. Already late. So let us continue now. So the next concept is relative velocity, right? Relative velocity. As part of motion in a plane, relative velocity. So what is the relative velocity and how to calculate this in different cases? Let's try to understand briefly. So relative velocity, the meaning of the terms itself very clear that velocity relative to something. It's called relative velocity. Relative means with respect to something. So in general, so this we are not going in detail the discussion of these concepts. The main points we will discuss, okay, as we are having less time. The relative velocity or velocity of one body with respect to another, in general we can give the relative velocity of body A with respect to B. In general, relative velocity or simply is velocity of body A with respect to B. No need of this word. Velocity of body A with respect to B means that is nothing but relative velocity. Is given by VAB, where A is the first body, B is the second body. VAB is equal to, as A is the first body, velocity of the first body, that is A, velocity of first body plus reverse velocity of B, velocity of first body plus reverse velocity of second body, or velocity of second body. Here we are taking as B, we are considering second body is B, so reverse velocity of that. This we can consider as the general formula for relative velocity of two bodies. In vector form, we can write, say, for example, let us see some examples. If body A is moving with velocity VA, the body A is moving with velocity VA towards the right, you can consider this as the positive x direction, and B, another body B is moving with velocity VB towards the right only, that is along positive x direction only. Then you may ask, find velocity of A with respect to B or velocity of B with respect to A also. So here BAB is equal to what? BBA is equal to what? According to this general relation, velocity of A, the first body, velocity of the first body plus velocity, reverse velocity of second body. Here you can see velocity of first body is A, right? Or you can see velocity of A. The velocity of, instead of B, you can also say velocity of second body. Second body. Here that is B. Here first body is A. Velocity of the first body A plus reverse velocity of second body, that is B. So here, first when you are trying to find the velocity of A with respect to B, as first A is first one, so as it is moving to the right, you have to use sign conventions properly while dealing with relative velocities. So velocity of A as it is in positive x direction, we will take as it is VA plus reverse velocity of B. B is already in positive x direction. Reverse velocity of this will be taken in this direction, that is minus VB. So plus of reverse velocity of B will be minus VB. So in vector form we can take this with the sign we are taking means this is nothing but vector form. VA vector minus VB vector gives velocity of A with respect to B. Is it clear everyone? Similarly, velocity of B with respect to A, when they both are moving in same direction, that too along positive x direction, then we can take velocity of, here the first body is B. B is the first body. Velocity of B is already moving in positive x direction plus reverse velocity of A. A is in positive x direction. Reverse velocity of this will be in negative x direction. So this will become minus VA. So minus VA. So this will give you VBA. Is it clear? In vector form. If you want the magnitude of this, here they both are moving in same direction. Or you can say parallel to one another. So same direction. Whereas, so this gives you velocity of one with respect to another. Let us see the next example. If the two bodies are moving in opposite direction, then how to get the velocity of one with respect to another, that is relative velocity. So here itself, let us take that example. Next example. Note down quickly. Next example. If A is moving in positive x direction with velocity A and B is moving with velocity VB in negative x direction, in opposite direction. So the two bodies are moving opposite to one another, maybe towards each other or away from one another also. In opposite directions. Opposite directions means they may approach there or they may recede. They may move away from one another also. Both are cases of opposite directions. In these cases, velocity of find VAB. Find VAB is the question. Find VAB. VBA or VBA means what is that? You have to understand. Find VAB and VBA. First VAB. VAB is equal to what? A is the first body. So it is moving in x direction. So velocity of first. Plus reverse velocity of B. VB is already in negative x direction. Reverse of this will be in positive x direction. Are you getting this? It will be in positive x direction. So plus VB. So in vector form, we can take this. Is it clear everyone? Whereas VBA is equal to what? B is the first body now. B is in actually negative x direction. With the sign if you want to take, minus VB. With the sign you have to take. That is the important thing you have to take. VB plus reverse velocity of A. A is already in positive x direction. Reverse of this will be in negative x direction. So minus VA. So minus VA in vector form. So minus VB minus VA or minus of VA plus VB. Or you can also take as minus of VA plus VB gives you VBA. What you can observe from this two is velocity of A with respect to B means there are two vehicles. If you, this is A vehicle, B vehicle. Velocity of B with respect to A means when you observe from A, what is velocity of B? Whether it is moving or at rest. If both are moving same speed, say for example, B is moving with the speed of 10 meters per second, A is also moving with 10 meters per second in same direction. So then, if he observes that both started the motion, it is an observer in A is seeing B. So velocity of B with respect to A, when you see here at time t equal to 0, B is here, but both are moving. After 10 seconds, if you observe, he is there just beside only. Because both are moving same speed. Means they cover same uniform speed or constant speed or same speed means they cover equal distance in equal interval of time. So if they cover 10 meters, he also covers 10 meters in 1 second. If he covers 20 meters in 1 second, he also covers 20 meters in 1 second. That is the meaning of same speed. Okay. So both will be side by side. So relatively there is no change in position. There is no change in position. So we can say, he says that, the observer in A says that he is at rest because his position is not changing with respect to him. When a body is in motion, if the position of a body changes with respect to surroundings and also with the time. Here with the time, with respect to surroundings, the position of the body is not changing. So this is said to be at rest even though it is in motion. If another person who is observing on the ground, he will say that both of us are moving. Both of us A and B are moving. But A says B is at rest because both are moving in the same speed in the same direction. That is the meaning, physical meaning of relative speed. Is it clear, everyone? So that you can understand in this case, both are moving in this case. If VA minus VB, both are equal, VA minus VB equal to 0. Yes. If one is moving with a larger speed and another one is moving with smaller speed, then the relative velocity will be in the direction of the larger one. This is larger, it will be in positive direction. This is larger, relative speed will be in negative direction. That is the meaning of it. Okay. So we are not going again. So we get to understand this so deeply and more clearly with so many examples. You can try with so many examples, real life examples. But we have to just look at the main important points now. Now this is briefly about relative velocity of two bodies moving in the same direction and in opposite direction. Opposite direction means towards each other or away from each other also. It is applicable for both cases. So it is applicable for both cases. From this what you have to understand is velocity of A with respect to B is equal to sum of the speeds. It is also sum of the speeds, but negative sign says that in opposite direction. If you see velocity of A as seen from B is in positive x direction. As seen from velocity of A as seen from B is in opposite direction. That is the meaning of it. Okay. This is one simple point about how to find the relative velocity of one body with respect to another body. Now, one generalized formula. This is vector notation. Vector notation. If the bodies are moving parallel to one another, or if one body is moving horizontally but another is moving at some angle with respect to this, in such case, vector form you can say like this only: VAB equal to VA vector minus VB vector, or VA vector plus VB vector. But while finding the magnitude, we have in general magnitude of relative velocity VAB is given by square root of VA square plus VB square minus 2 VA VB cos theta. And for this cos theta. Here theta is angle between the velocity vectors. If both are moving in the same direction, theta is what? 0. So A square plus B square minus 2AB is A minus B whole square. So A minus B whole square come out of the root and becomes A minus B. A minus BB. Correct? If theta is 180, they are moving in opposite directions. Theta should be 180. Cos 180 is minus 1. Minus of minus plus. So A plus B whole square. VA plus VB whole square under root becomes VA plus VB. Yes, VA plus VB. So like that we will get. Okay. So this is the general, again one more generalized relation. Note on this. Next, we'll see the next case, rain umbrella problems. As part of relative velocity, rain umbrella problems. Here we will see with some examples what is this rain umbrella problems means. The concept of relative velocity can be understand here in this scenario. Again here we will come across some special cases. So one of the case that is considered is generalized formula this only. Velocity of A with respect to B is velocity of first body with respect to second is velocity of first plus reverse velocity of second. That you have to remember as a generalized formula. Now, who will understand this? Let us try to understand. Case 1. If rain is falling vertically down, so without giving so much of theory, directly you can diagrams, you can take it and you have to understand. If rain is falling vertically downwards with velocity VR, velocity of rain vertically downwards. So, if the rain is falling vertically down and if you are standing there with an umbrella, how you will hold the umbrella? Like this, vertically up. So as it is raining, vertically downwards. Got it? If you are standing, but rain is falling down, but you are also moving some velocity. Simply walking like this is okay, but you are walking little fastly. Okay? In such case, if you hold the umbrella like this, will you protect from rain? No, because the direction of rain will changes. You can experience that while going in bike or a vehicle. Right? Even if you are standing and in the rain, you feel like rain is falling so nicely. But when you are moving in a vehicle, the rain is hitting you tap, 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 tap. Right? So that means the relative velocity will actually plays the role there. So to understand that, let us say the man is moving horizontally in a horizontal road. So this is the velocity of man. Velocity of man in horizontal. Then the velocity of rain with respect to moving man is what? Velocity of rain with respect to moving man is equal to, according to our general relation, velocity of the first plus velocity of reverse velocity of second. The first one is rain. Velocity of rain is downward. Let's keep it as downward only. Velocity of rain plus reverse velocity of man. Reverse velocity of man. Actually, this is in negative. We can say with sign convention if you want. This is plus x, plus y, minus y. You can take this as in minus y direction, and you can write minus VR also. No problem. So this is minus VR because of negative y direction. This is in negative y direction. And reverse velocity of second is man velocity. It is already initially it is in positive x direction. Reverse of this will be in this direction with the same length of plane. Is it clear? So this is minus Vn. So minus Vn vector is velocity of rain with respect to moving man. Is it clear? This is the mathematical expression for this, and this is the pictorial representation. So how to represent now? The question here is, if while moving, if you hold the umbrella like this, you cannot protect from rain. So to protect from rain, in what direction the person has to hold the umbrella? At what angle with respect to horizontal or vertical is the question. So to understand that, this is the velocity of rain, this is the velocity of man. Now, velocity of rain with respect to man will be, the resultant of this will be this. This is first one, minus Vr, minus Vm. This is minus Vr, minus Vm. Resultant of these two from triangle of acceleration, this is the resultant. Vrm. Is it clear? So it is in this direction. So angle made by this with respect to horizontal, if we take this as theta, but actually speaking, tail to tail you have to measure the angle. But with respect to this, if you want to know, this means here you can draw this horizontal, and this one, if you extend here, what is this angle if you say theta? Symmetrically, this angle is nothing but this angle. Then you have to project this horizontal component is this, and vertical component here. Then you have to understand. But for this, simply, if you want to know what is this angle with which you have to hold the umbrella with respect to horizontal, you have to take this as a right angle triangle. So from this, as you know, this is Vr, this is a minus Vm, then theta, tan theta is equal to, it is like opposite side by adjacent side, only if you take positive values, modulus of Vr by Vm gives you the angle with which you have to hold. Means with respect to horizontal, how you have to hold the umbrella. If you are moving like this, you have to hold the umbrella like this, slightly. If you are holding like this, rain instead of falling like, it will fall like this. That is what you have to understand. Rain with respect to moving man will come like this if you are moving. So, whereas with respect to vertical, if this is the angle, let us say this is beta or some alpha, this is theta, let us say this is some alpha. With respect to vertical, with what, how much direction, how much angle you have to tilt this. With respect to vertical, earlier you are holding like this. With respect to vertical, how much angle you have to turn this umbrella. If you want to understand that, this like this. With respect to this, how much you have to turn. With respect to this, how much you have to turn. This and this both are same. Alpha and alpha. To understand this, we have to now consider this is a right angle triangle only, but for this angle, this is opposite side, this is adjacent side. So in that case, the angle, the direction of umbrella with respect to horizontal is theta, whereas with respect to vertical is alpha is equal to opposite side by adjacent side, that is tan inverse of opposite is Vm, adjacent is Vr, Vm by Vr. Only magnitude you have to consider without negative sign. Is it clear, everyone? So these are the important points you have to keep in mind related to what is that rain umbrella problems. This is one case, basic case. Here we come across few more special cases. Let us see quickly. Copy this fast. Copy it, everyone. Right. Next, another case. Another case is right. Another case. The case 2 is if, of course, rain is falling vertically. It is raining vertically down. That is, rain is falling vertically. It is raining vertically, but so in another case, instead of vertically falling down, let us consider it is raining at some angle with respect to vertical. This is vertical. Here, a man is moving. Horizontally. So here already it is raining. Rain is falling. The velocity VR at some angle. Let us say theta with respect to vertical. So now we are standing here. It is raining like this from your back. So you have to hold the umbrella like this. Yes? Yes or no? Whereas if you are moving, now you are moving. So this is your first velocity and the first vector. The man is moving with the velocity Vm forward direction. Then obviously because of the motion, the direction changes. How? That is velocity of rain with respect to man, moving man, is equal to velocity of the first, that is velocity of rain. Okay, let us take it as vector quantity. It's not in exactly vertical direction, but some angle is there. So let us take it as a vector quantity. But actually speaking, if I want to take in vector form, resolve into horizontal and vertical components. So to understand that, let us see specifically. So this is theta. So if you resolve, this is theta, right? VR, if you say this is y direction, negative y direction, this will be VRY component, and in this direction we get VRX. Is it okay? VRY and VRX. So you can write, actually speaking, let us take this afterwards. First we will take VR vector is equal to VRX. X is in positive x direction. I cap, y is in negative direction, minus VRY j cap. Can you write like this? Velocity of rain is a combination of these two components. That is velocity of man. Man is moving only in positive x direction. So velocity of man is equal to Vmy cap. Now velocity of rain with respect to man is equal to velocity of rain plus reverse velocity of man. So velocity of rain plus reverse velocity of man. Reverse velocity of man means you have to take this as velocity of rain. This is in positive x direction. If you reverse this will be minus Vm. So minus Vm vector. Are you following? Now Vr is this. Vm is this. If you take the I components, you can write this further as Vrx minus Vm. Vrx minus Vm into I cap minus Vry j cap. This is the velocity of rain. Vertical. Mathematically, pictorially, what is the velocity of rain with respect to man? So this is the one. This is Vr. This is minus Vrn. Resultant will be in this direction of Vry only. Is it clear? Vry only. Provided if it is the velocity of having some particular value, then this will be velocity of rain with respect to man. Now, even though rain is falling like this, when he is standing, he has to hold the umbrella like this. Because of the motion, he can hold like this only, vertically. It appears like falling down. When he is moving, when the rain is falling at some angle, and that condition, if it is moving, it appears like it is falling down. If it is falling in this angle, then it appears like it is falling vertically down. Okay, that is the meaning of it. So mathematically you can understand from this, and pictorially you can understand from this. So we can say here nothing is what direction you have to hold the umbrella. Vertically, that's it. So that means from this angle to this angle, how much angle you are holding, turning, that much angle you have to turn towards vertical. That's it. Okay, that is what you can understand from this case. Whereas you may come across some other cases also. If the man is moving with some speed, a particular speed is so that if it appears, the question may come like this: for the rain to appear to be falling vertically down, what will be the velocity of man if you are asked? Velocity of man, you can write this as, we try to bring it here, you can say velocity of man is equal to velocity of rain minus velocity of rain with respect to man. In this kind of questions also we come across. So magnitude of this is equal to Vm is equal to square root of Vr square plus Vrm square, that's it. Okay? But Vr square means this components will come again. That you have to find first magnitude of Vr, then you have to substitute here. Okay? This is how we can say. This is the kind of questions we come across based on what you call rain umbrella problems. Next, another possible case here is, let us see here, case 3. Case 3 is, it is raining at some angle with respect to vertical, as this like in this case. This is vertical, it is raining, and this is horizontal. It is raining with the velocity Vr at some angle theta. And a man, when it is moving a particular speed, for the rain to be appear to fall vertically down, the velocity of the man should be this. But if the man speed up, then that speed, then so that if this is little larger, if we take the reverse one, the velocity will come up to here, from here to here. Then resultant here, this is the case, so resultant is vertically down. If it comes little to here, resultant will be till here. That means velocity of rain with respect to moving man will be at some angle, so he has to hold, instead of holding umbrella like this, he has to, instead of turning to right, straight, has to turn like this, because the rain appears to fall like this, by moving like this. That is the meaning of it. So through how much angle he has to rotate, or what is the velocity of the man, this kind of questions will come across, then you have to remember these cases. So now, if the man speeds up little bit, so that in this case this is the velocity of the man, we have to take this what you call length of this vector into account. That gives the magnitude. So length of the vector into account. So now the reverse velocity will be till here, we have to take minus Vm. So now velocity of rain with respect to man is equal to velocity of rain as it is, plus reverse velocity of man is minus Vm. So vector sum of these two, if we take, this will be the velocity of rain with respect to this man. This is velocity of rain with respect to man. Is it clear? So pictorially you can understand this. Now, the direction of umbrella with respect to vertical you can take it as alpha. With respect to horizontal you can take it as beta. Any angle you can take. Okay, but if it is, if this is Vr, again if you resolve this, because it is making an angle theta with this component will be, is y component, right? Vry, and another component will come here, this will be parallel to this. So this component, are you following this? This component will be Vrx, this will be Vrx, right? So this will be parallel to this. So now, if you want to find what is this, you can say, in this Vm, if you subtract Vrx, you will get this much. For this triangle part, if you want this side, you are following this carefully? Yes? So, this side is equal to Vm is actually minus Vm, only magnitude if you want, Vm minus Vrx will give you magnitude of this. So that if you take, then you will get alpha. So alpha is equal to tan inverse of, this opposite side is modulus of tan inverse of Vm minus Vrx. This is opposite side, right? Adjacent side is Vry. This you have to understand carefully, guys. Otherwise you will confuse. Okay? So this will be the direction of umbrella when the man speeds up so that the minus Vm is extending beyond vertical. Then the resultant velocity of the rain appears to be falling at some angle with respect to vertical. It is given by alpha equal to tan inverse of Vm minus Vrs by Vr. Follow carefully, then it is very easy. Otherwise, you will confuse what is VR, and so on. You will confuse. Okay? So there are like so many special cases will come across. Okay? So I have given you case 1, case 2, and case 3. Even some other cases, special cases also can understand. So let us. These are enough. I am winding here about what you call rain umbrella problems. Briefly, this is enough. Next one is about what you call the important concept related to relative velocity. Usually you get the questions based on relative velocity is from rain. What is that? River boat problems. River boat problems. Let us see briefly. So what is this concept of river boat problems? How to deal with them. So next, have you copied this? Copy that. Finish everyone? So in these places, we can take numerical values. I am discussing general examples. General examples. Here we can take some numerical values. A man is moving with the speed of some 10 meters per second. The rain is falling with the speed of some 3 meters per second or 20 meters per second. There are some numerical values you can take and we can deal with. Okay. Right. Next, write down some heading. River boat problems. Finished? River boat problems. Right. River boat problems. Under this concept of river boat problems, we come across 3 special cases again here also. One is, we can call it as actually 1D case also. Relative velocity in 1D, you may get the questions based on first 2 cases. What are those cases we'll see. And the second, third case come under 2D, actually 2-dimensional relative velocity case. Okay. We'll see all the cases once, one by one. First case is downstream motion. Second case will be termed as upstream motion. Third case will be considered as general motion of a boat in a river. So let us see first downstream motion case and upstream motion case. What is downstream and what is upstream? So first case is downstream motion. Downstream motion. Downstream motion. What is this downstream motion? To understand this, let us consider there is a river. This is our river and water is flowing like this. River is flowing, let's say river is flowing, means water is flowing. Means the entire river is not moving with land. So river is flowing means water is flowing. So this is velocity of river direction. We consider this with a straight line, velocity of river. The river is flowing towards right. Now, if you have a boat here, this is your boat. Special boat. Yes, this is our Velamar boat. Okay, special boat, and you are sitting in this boat, and you are, if you are traveling in the direction of the river, we call it as downstream motion. You are said to be in downstream. Is it clear? When the boat is moving, or when you are sitting here, and you are moving in the boat along the river flow, in the direction of river flow, then you are said to be in the downstream motion. That means when you are moving in, say, in the direction of river flow, so to cover some distance, for example, to cover some distance d, how much time it takes? How much time it takes? This is river velocity. Velocity of the boat with respect to, this is if you say velocity of boat is also moving in the direction of river flow with respect to river. With respect to river. Now the river is there. Imagine the river is there, it's flowing. Okay? And a boat is also moving. If you are observing from bank of the river, from outside the river, you feel like if he measures the speed of the boat with respect to river, he will be moving some, say for example, some 10 meters per second. But when you observe from the outside, with what speed the river is flowing, plus with what speed he is moving, together will be observed as the velocity of the boat with respect to ground if you observe from outside. What does that means is, velocity of boat from the relative velocity concept, velocity of boat with respect to river is equal to boat is moving. Boat velocity of boat means if it is velocity of boat only, velocity of boat only means with respect to something, with respect to ground, stationary ground, is VB. VB is to the right. Velocity of river means velocity of river with respect to ground. VR means there also should be one more, what you call, relative parameter should be there. We will not represent that. Still should be, we have to remember that no other parameter is there means with respect to stationary ground, that is the meaning of it. You have to keep in mind. Okay. So velocity of river means with respect to ground. Velocity of boat means with respect to ground is both are in same direction. If two objects are moving in same direction, what is velocity of relative velocity? If the first relative velocity of the first plus reverse velocity of second. Yes or no? So the first one is boat. Velocity of boat with respect to river is the ultimate velocity of boat. Boat is moving in the positive direction. Yes, VB. Plus reverse velocity of rain. This is in positive direction. Reverse velocity will be in new direction. So minus VR. Are you following this? Then velocity of boat as observed from the velocity of boat means with respect to ground. Velocity of river with respect to ground. So from this we can say velocity of boat is equal to, means velocity of boat with respect to ground is equal to velocity of boat with respect to river plus velocity of river. Is this clear everyone? So if you observe from the ground, boat is observed to be moving with velocity which is equal to velocity of boat with respect to river plus velocity of river. That means it is appears to be moving faster in downstream because the river is dragging this boat because of its flow. Okay. Now to cover this distance, what is the time it is taking? If you are asked to find time taken to cover a distance, you can write here. Time taken to cover a distance in downstream. Write down clearly these words. Time taken by the boat. Time taken by the boat to cover. Time taken by the boat to cover a distance d. A distance d in downstream. Time taken by the boat to cover a distance d in downstream is T is equal to time is what? Distance by velocity. Distance by velocity. If the time distance travel is d, then d. With what velocity it is traveling with respect to ground? From ground. With respect to ground. So it is equal to velocity with respect to ground is this much. Velocity of boat with respect to ground. So there is VBR plus VR. This is the velocity. So distance by this velocity will give you the time in downstream. Is it clear everyone? This is the first case. Second case is upstream. Upstream motion. Let us see upstream motion. Is it clear everyone? Right? See, in case of upstream motion, case 2. Let us say this is case 2. Upstream motion. What is upstream? Sorry, downstream is this. Upstream means if the river is flowing in one direction, in opposite direction if the boat is moving, that motion is called upstream. If the boat is moving in the same direction of river flow, it is called downstream. If the boat is moving in opposite direction to river flow, it is called upstream. Upside the river flow. Means opposite side to the river flow is called upstream motion. So let us consider the same case here. This is the river. Okay. So here let us say the river is water in the river is flowing in this direction. So this is velocity of river. Velocity of river direction is towards the right. And a boat is moving. There is a boat. Which boat? Special boat. It is moving in opposite direction. It is moving in opposite direction. So velocity of boat, if you observe, velocity of river, if you observe from the ground is towards right. Velocity of boat, if you observe from the ground, it is towards the with respect to ground is this, but with respect to, actually speaking, with respect to, even though it is trying to move forward, if velocity here, some other case will come. If velocity of river is lesser, it may move upwards. If there is more dominant, it may drag the event downward only. That is also possible cases there. But we are considering a case that velocity of the boat is dominant than this, so we will move in upstream. Okay. So then velocity of boat with respect to river will be what? Velocity of boat with respect to river is equal to what? Velocity of boat is in negative x direction. Negative x direction. Let us take this is the velocity of boat direction plus reverse velocity of what is that? River. So if you consider this, that is minus VB minus VR you can take, or you can take it as what is that? Minus of VB plus VR, or you can take like minus VB minus VR only. Right? From this you can say velocity of boat with respect to river is this. So velocity of boat with respect to ground is from this. If you bring it here, it becomes plus, right? So plus VB is equal to minus VR plus VBR minus VBR, or you can say minus of VBR minus VR, or minus of this plus this. So here the sign tells about the direction of flow. The direction of velocity of boat, as you observe from the ground, is in opposite direction to the river flow. That is the meaning of sign. So if you observe in this case, if you observe from the ground, velocity of boat is nothing but this one. If you observe from this, it is velocity of boat is in this direction, opposite direction. Is it clear? So the other way, you can also say velocity of boat, velocity of boat with respect to ground is minus of this. Minus of this. Now what is the time taken by this to cover a distance d? What is the time taken by this to cover a distance d? So you can take time taken t is equal to, here as we have discussed, if it is trying to move in this direction, if it is dragging along this, then the other case will come, different case will come. So that is VR plus VB together will give you the velocity of the boat as you observe from the ground. So here in this case, time taken is distance travelled by velocity. This you have to take. Downstream velocity. So actually, but here, this is upstream velocity. But here under that other special case, we may take this as VBR minus VR also, provided which is dominant. Here you have to be a little careful. That's why I told already. So you can take this as only the manual part if you want. You can take VBR plus VR. Velocity of boat with respect to river is this plus VR gives you time taken. VBR plus VR, or you can take VBR minus VR under the other special case. Okay. So this gives you what is that upstream motion case and time taken to travel a distance d in upstream. Okay. So these are the first two cases. Then the third case is little more important one. So let us see what is that. Generalized case. That means if a boat is trying to cross the river, which is having a width of d. So have you copied this? And it is having a width of d. Then, so in some cases in the books it will be given as that what is that? The time taken to travel a distance d. In upstream will be given as it is d by VBR minus VR. VBR minus VR. That's what I said, under some special case. Okay, so you have to take accordingly those cases. Okay, so this some cases are what you call applicable, and this is another case it is applicable. Okay, so this you have to understand carefully. Next, let's see the third case. Third case. That is a generalized case. Generalized case. What is this generalized case? Is if there is a river of width d, this is the width of the river is d, and if a person, you can say a boat is trying to move, or you can say a person swimming across the river also you can consider. Both are similar kind of cases. If a person is starting on one bank of a river at point A, he is trying to cross this river and to reach this point B exactly in opposite bank. The point opposite, on the opposite bank, exactly on the other bank. Right? So, here we come across two cases. Here we come across in the generalized case, we will come across two cases. One is shortest distance path and shortest time path. If you want to just reach this exact opposite point along this path, we call it as the shortest distance path. One more generalized case now is that I don't want to give you that. So here I will give you this two cases only. What is that? Shortest distance path and shortest time path. In shortest distance path, in this path to cover, it has to start its motion. It has to, you can say the person, a swimmer, or the boat you can say. The boat has to start its motion at some angle theta. So this will be velocity of the boat with respect to river. With respect to river, the boat has to start its motion at some angle with respect to the vertical. With vertical. Then we come across here, because it is making an angle, as river is flowing in this direction. You can say this is velocity of river. The river velocity will be gradually, slowly pulling in the direction. So by the time he reaches here, so it will go like this and like this and like this and like this, and finally by the time he reaches this point, he will reach this point. Whereas if we start in this direction itself, as the river is pulling in this direction, by the time it comes here, it will be pulled like this, then it will be, after coming here, it will be pulled like this, so he may reach somewhere here. If we start in this particular, what you call, perpendicular direction to the river. So, that is not the shortest path. This is the shortest path. So, to cover or to cross the river in shortest path, boat has to start its motion at some angle with respect to the vertical. Or a person has to start swim at some angle with respect to vertical. Then this is the distance. If you resolve this into a rectangular component, you get this will be VBR cos theta, and here we will get VBR sin theta. Out of these components, this component will be used, this component of velocity will be used to cross the river. This will not be utilized for crossing the river. Okay, I mean crossing the bank. Crossing. So because velocity of river and this will competing with one another. This velocity component only will be used to cross it. Is it clear? So now, if you are asked to find what is the time taken to cross the river, the distance by velocity. The distance is nothing but width. Velocity is this. So this by this gives you the time taken to cross the river in shortest distance path. So what is the time taken to cross the river in shortest distance path? T is equal to D by VBR cos theta. Is it clear? Yes? Fine. So, if you consider this is the vector, this is one vector, and this is the vector, and if you take this is the river velocity, then you may deal in the other way, another kind of what do you call it, the components also. Here, some special cases also you can consider. Instead of reaching this point, he is reaching here. That means he has dragged through some distance. He has dragged through some distance. So, in which case he may exactly reach this point is one of the special cases. When velocity of river is exactly equal to VBR sin theta, then these two components will not play any role. These two will cancel out each other. Only this will be used to cross. If VR is greater than VBR sin theta, so in the horizontal component will be dominating in x direction, and along with this, so resultant will be in this direction. So if we, instead of reaching this point, the person may little he cross and reaches the right side point. If VBR greater than this. If VBR is lesser than this is greater means if it is both are equal, you may reach this point. If this is greater, is still the difference between them will be in this direction. So because of that, he will not reach this point. He may land up by that time he crosses the river on left side point only. These 3 points are remember. I'm giving you these 3 points orally. I'm giving you these 3 points orally. So the first point only I have given you. What is that? Oh, the main thing. To cross the river in the shortest distance path, the possible condition should be VR is equal to VBR sin theta. To cross the river in shortest path, the valid condition should be VR is equal to VBR sin theta. Then this component is used to cross the river in this time. So then time is equal to d by VBR cos theta. Simple case. Okay? Right. Next, under this only, this is called as shortest distance path. Then you can see this is one shortest distance path. Crossing the river in shortest distance path. The second case under the case 3, second point is crossing the river in the shortest time path. Shortest time path. Shortest time path. So note down next second point here. Shortest time path. Shortest time path. What is this shortest time path? To cross this river in this direction, he has to start at some angle. To cross the river in shortest distance path, the boat or swimmer has to start at some angle. So he has to overcome the river flow and then he will reach here. So for this, it takes more time than the shortest time path. So even though he crosses the river in shortest distance path, but for this purpose, in this process, it takes more time. It takes more time. Whereas in shortest time path, it takes the least possible time to cross the river from point A on one bank to another point B. Not actually another point B, he is trying to cross the river, but if he starts this motion in perpendicular direction, to cross the river, he has to start the motion. The boat has to start the motion perpendicular to the river flow. If the river is flowing in this direction. Then, as river is flowing in this direction, it will drag him, so he will not reach this the other bank here. So river is pulling in this direction, so he will land somewhere here at some point C. That means he has traveled some distance. This distance you can see BC is expressed as x. This is called as a drift. So in this part, this is velocity of the boat with respect to river. This is the velocity of the boat with respect to river. This is velocity of the river. So the velocity, the resultant will be this one. The velocity of boat with respect to ground will be in this direction. So because the boat velocity with respect to river and the river velocity are both adding up, this plus this will give you this pictorially by using what you call triangle of accretion. This is velocity of river. VBR plus VR gives you this velocity of boat with respect to ground. Or simply you can say velocity of boat. This is sum of these two. He can reach this point within shortest possible time. So, but the path of this is more than this d. What is the width of the river? So this is not shortest path. This is longest path than this path. But it takes less time. Even though path length is more, he will reach in less time. Why? Because not only his velocity, river velocity is also adding up to travel. So he will reach faster because of the more speed. Because of the more speed, he will reach faster and quickly. So in shortest time. So in shortest time path, he will the boat or the swimmer has to start its journey perpendicular to the river flow. That condition I have to remember. Write down. So to cross the river in shortest time path, the person or the boat, the swimmer or the boat, you can write like this. To to cross the river in the shortest time path, the swimmer or the boat has to start his journey, perpendicular to river flow. Start their journey perpendicular or normal to river flow direction. Perpendicular to river flow direction. Perpendicular to river flow direction. Got it? Whereas to cross in shortest distance path, the swimmer or boat has to start at some angle theta with respect to vertical. These conditions you have to remember. The direct questions you may get based on these conditions also. Concept based questions. Okay. Next, another point is, in this you have to remember is, what is this horizontal distance travel or drift? We call it as drift. So this distance is due to this velocity of river. So this drift is nothing but x. Distance is equal to velocity to time. Velocity, which is taking the boat and start reaching here, this direction is the river. So velocity of the river into time taken to cross this. What is the time taken? Here you can take the time taken is nothing but this. Time taken to while crossing the river, time taken is nothing but distance by, what is this? When he is started its motion in vertical direction, you can take directly VBR, or this time if we are considering here, you can take it as a d by VBR cos theta also. Okay? So this accordingly you have to take VR into time t. And t will be distance by velocity. So distance by what velocity? The resultant velocity. So you can take this as the resultant velocity. Time taken to cross this is nothing but distance by resultant velocity. In this case, this is the resultant velocity. VB. VB will be VBR plus VR in this case. In this case, it is VBR cos theta. In this case, it will be VBR plus cos theta. Sorry, VBR plus VR will be the resultant velocity. So if you substitute this, you get a drift. These points, based on these points, usually you will come across the questions in what do you call it? River boat problems and rain umbrella problems. These are the simple and important cases related to relative velocity part. Okay? I hope these points are clear. So numericals, if you go through, as I told, instead of using these letters, you can use some numericals so that we can understand how to work out this. So let us try to work out some numericals. So we have the volume. What is the time? Okay, so you can take some 20 more minutes, 30 more minutes, 1 more hour. Right. So motion in a plane. So have you practiced any questions based on projectile motion? So here the questions are given based on this only. Okay, so here based on these, very few questions are given. We are trying to find volume. let's see one simple question here. Question number 7. See question number 7. A man standing on a road, has to hold his umbrella at 30 degrees vertical to keep the rain away, to avoid from the rain. He throws the umbrella and starts running at 10 km/h. He finds that raindrops are hitting his head vertically. The actual speed of raindrops is. Which case it is? Which case it is? See, the raindrops, usually this is vertical. Question number 7. Actually, this is vertical, this is horizontal. Initially, the man is standing on the road and has a whole umbrella at 30 degrees with vertical. 30 degrees with vertical means vertical. This is the at this angle, theta is equal to 30 degrees. He is holding the umbrella, right? And now he has just thrown the umbrella and he is running with some speed. This is the speed of rain. Speed of rain, velocity of rain. Now he started moving with the velocity of Vm. With what velocity? What velocity? 10 km/h. And he started moving with the velocity of 10 kmph, km/h. He finds that raindrops are hitting his head vertically. So for this speed, the raindrops are hitting vertically means what is the velocity of rain with respect to moving man is vertically down. That means this is minus Vm. So velocity of rain with respect to man is vertically down. Is it clear? For this particular case, or for this case to be possible, what should be velocity of rain? What should be the velocity of the rain is the question. So the actual speed of the raindrops is. What actual speed of the raindrops is? So the scenario is clear. The rain is falling at an angle 30 degrees with respect to vertical, so he is holding the umbrella. Now when he is standing and holding at 30 degrees, he is get rid of the rain. Now he is thrown the umbrella and is moving with this speed. Now he feels like rain is falling vertically down. That means relative velocity of rain with respect to man is vertically down. For this to happen, exactly this will be meeting here, reverse velocity minus Vm. So we can consider here, what is this? Relative velocity. Vrm is equal to what? Vrm is equal to velocity of rain minus Vm. Velocity of rain, you are asked about velocity of rain. Velocity of rain with respect to man is given, speed is not given, angle is given. Then how to understand this? How to resolve? This is Vr, so this component V is nothing but Vrx. Vry, negative y direction, Vry. This will be Vrx. So what will be? How to find then velocity of rain? Here Vrm is coinciding with Vry. So what will Vrm is equal to Vry? When you say is equal to Vry, but Vry is nothing but Vr cos theta. But Vr is unknown, Vrm is also unknown, theta is only known. So with the help of this you cannot find Vr. But the other one is Vrx is this parallel to this. So this is Vrx, and Vrx is nothing but, what is this? Vrx is nothing but Vr sin theta. Vr sin theta. Vr is Vr cos theta. So this is coinciding with this. So you can say that Vrx, that is equal to Vr sin theta, is equal to Vm, magnitude wise, is equal to Vm. Then as theta is 30 degrees, you can say Vr is equal to Vm by sin 30. What is sin 30? 1 by 2. What is Vm? Vm is 10. It is 1 by 2. So it is 20. So what you can observe here? It is observed to be 20 kmph. So you have to cross check whether you can use this condition or this condition. If you use this condition, both are unknowns. You cannot use that. But if you use this condition, Vm is known, Vr is unknown, theta is also known. So this you can calculate easily. But you have to cross check by using resolution of vectors. If you are clear, if you are thorough about the resolution of vectors, it is very simple. Otherwise, again, we confuse if you are not clear about the resolution of vectors. Okay? So what is the answer? 20 kilometers per hour. So options are given as 20, 10 root 3, 20 root 3, 10. So 20. Option A is the right one. Okay? So this is how you have to deal with it. So this is a direct question. So I am winding the session now. I hope we have followed this simple points. We go through once again and try